Hello student, welcome once again to another session of organic chemistry where we will be discussing one interesting question in regard to the IIT Advanced or JEE Mains or NEET examination. So this particular question is of the type single integer type question where you have to uh, uh, write the answer in terms of integer. So here is the question which seems like easy. The starting material is to be treated with OH negative followed by H positive, and lastly you have to heat it. So the examiner is asking us that how many of these statements written below for this particular reaction is to be the correct one. So the examiner is asking many things in this discussion. They are asking decarboxylation in the step 3, SN2 in the step 1 and so on. And also in the last options you could also see that stereoisomerism or racemization is also asked for the compounds formed during this sequence of reaction. So although seems like easy, but it is not so easy. It take into account lot many different aspects of organic chemistry. If you are quite clear with all the in and outs of the organic chemistry in terms of reagents, in terms of the mechanism, in terms of stereochemistry, then only this type of a question can be addressed with. So let's start our discussion. Video may go in length, but do stay. You would feel quite strengthened after the discussion of this particular problem. So the starting material, if you would see, is a sort of, you can say this is the alpha carbon. I can say this is alpha alpha dihalo or dichloroketone type of a species to which OH negative is being treated with. And they said OH negative, you can use it in excess. Now here the first point of discussion would be this is delta positive, this is delta negative. Carbonyl group is polar in nature, and so is your carbon halogen bond. So now the question is this OH negative, and also you could see that this OH negative has a site of attack either on this carbon or in this carbon. If I attack onto the carbonyl carbon, then it would lead to nucleophilic addition type of a reaction. And if in case I just would attack onto the first carbon containing the halogen group, then it is a nucleophilic substitution. So here I would take this reaction through the nucleophilic substitution because of the fact that carbonyl carbon CO double bond C double bond O bond is stronger as compared to the carbon chlorine bond, and halogen is a good leaving group. So we will be saying nucleophilic substitution would obviously would predominate in this particular problem when we compare it with nucleophilic addition of the carbonyl group. So what we will be going for, we shall be then attacking first onto this carbon, and this would throw it out. And this in a way is a type of substitution which we call it as SN2. This is nucleophilic substitution of SN2. So always make it a point when you have a halogen attached onto the carbon next to the carbonyl group. This type of a substrate is very ideal for doing SN2 type of substitution. If you have SN2 type of substitution, because uh, SN2 SN2 substitution is a concerted reaction where bond breaking making happens simultaneously, and more is the polarity or more is the delta positive charge onto the carbon, more vigorous would be the attack, and the nucleophilic substitution would be very predominant. Now vis-a-vis, if I would compare it with, if the same entity you just would try to do it through SN1, this is a very bad substrate. It's a very bad substrate for a reaction to go through SN1. So SN1 would never happen, because in SN1 the X negative goes out in the first step and leaving behind a carbocation which is highly unstable, because carbonyl group would destabilize this carbocation. So this particular type of a substrate, the substrate where the second carbon to the carbon halogen bond is containing a carbonyl group, is a very good substrate for SN2 but very bad substrate for SN1. And also you always would remember that during the SN2 reaction of this type of a substrate, the rate of reaction is almost 10 raised to the 5 times more as compared to a normal carbon methyl chloride. Say for example, if I compare it with methyl chloride or simple alkyl halide, so this rate is very enhanced when you have a carbonyl group attached onto the carbon next to the carbon halogen bond. So what we said here is that first what would happen is that there is a substitution of the type SN2, and OH negative obviously would attack onto the both the carbons and throw out the two OH two Cl groups. So we would be getting two OH groups onto the same carbon. Now, all of you might be knowing it that the two OH groups onto the same carbon is not very stable. So, this would undergo dehydration, and dehydration OH from here, H from here, and you end up getting a very beautiful compound which we say it as to be phenyl glyoxal. This particular compound is being generated. Aldehyde is being generated. So what we reached here is that we have generated a compound which we are saying it as phenyl glyoxal. This is what you, and what is glyoxal if I would write once again for you. So this particular compound is called as glyoxal, and one of the hydrogen of the glyoxal is being substituted by phenyl. That way it is called as phenyl glyoxal. Now, as per the question, you still would have OH negative in excess. Now, again, what would happen? Here, you can think it like this, that this is delta positive, delta positive, delta negative. There are two carbonyl groups here, and OH negative can have the chance of attacking either this carbon or this carbon. Now, here we have to take into consideration the simple GOC viewpoint, that where it would attack. Obviously, it would attack onto that carbon which would have more polarity. Now we have to see which one is having more polarity. If I would just write once again for you and would show you which would have more polarity, obviously the carbon which is here, the carbon which is adjacent to the phenyl group would undergo resonance, and if it undergoes resonance, so what basically we have done, we have decreased its delta positive charge. This delta positive charge got decreased because of the engagement of resonance coming from the phenyl group. So obviously we shall then be saying that the OH negative would definitely be attacking onto the carbon which is at the corner. The corner CHO group is being attacked. Now, as a matter of fact, you also should know that when you have any aldehyde or ketone, aldehyde without any alpha hydrogen, any alpha hydrogen atom, we generally would say it like this: aldehyde without any alpha hydrogen atom is a very excellent substrate to bring about Cannizzaro reaction, or you many books say it as geographically different pronunciations are available: Cannizzaro or Cannizzaro, whichever way you would want to speak it. Cannizzaro reaction, the what is the substrate, what is the ideal substrate for any Cannizzaro reaction? In the Cannizzaro reaction, you would get uh, aldehyde without alpha hydrogen as a substrate, to which you are adding OH negative. So if it had have a alpha hydrogen, then aldol condensation could be a parallel reaction. But here, what we are able to see here is that we don't have any alpha hydrogen. Now, what I am referring to alpha hydrogen is the hydrogen attached to the carbon next to the carbonyl group. So here you don't see any hydrogen because this carbon did not have any hydrogen, nor on this side, because this is the function group itself. So what now we can think about is that OH negative definitely would attack onto this carbon. So once this carbon got attacked, this would go like this, and as we now proceed with it, is somewhat we are now taking the reaction through the Cannizzaro reaction. So here you have OH and H. Now what is the second step in the Cannizzaro reaction is, once this attack has happened, then thereafter is a intramolecular hydride shift. In this particular case, I would say this has to be intra Cannizzaro reaction. So I will make specially some video separately for Cannizzaro because it's a very lengthy, interesting topic to explain with. So rather I would also engage here. It is intra-crossed Cannizzaro. Intra-crossed Cannizzaro, in the sense intra means within, crossed means because there are two different types of um, carbonyl groups are there where they both of these carbonyl groups are chemically non-identical. So in that sense, it is crossed. If I would have started with a glyoxyl, in the glyoxyl, if you add OH negative, then I would be saying this has to be intra Cannizzaro because both are identical. Both carbonyl groups are identical in this case. So moving ahead, what next we can think about is a sort of intramolecular hydride shift. So intramolecular hydride shift would happen and this goes like this. So as a consequence, what you now would generate a O negative here and H comes here and this would become this would push, sorry, this O negative would push the H negative out and this would attack the CO group which is adjacent to it, and here this would become this entity, isn't it? Now we know for sure that carboxylic acid is a stronger acid as compared to any alcohol. If you talk of alcohol's acidity and carboxylic acidity, so carboxylic acid is more acidic acidity if I talk it like this. So that in a way shows that this H positive now would reach this one because carboxylic acid is a stronger acid. It would want to remain in the salt form and the alkoxide would abstract this H positive because it's a stronger base or alcohol is a weaker acid. So here you would get OH, H and here you would get something of this type. So what basically we have generated in a way is if I would write somewhere, so what we have generated, we started with this entity. This is the phenyl glycol we started with, and this phenyl glycol now have converted itself into a salt, a salt of a carboxylic acid, because in the options there was something written in terms of salt, that what salt do you get in this reaction. So second thing which you also should know, that many of times we people say it very categorical that Cannizzaro reaction is a sort of Cannizzaro reaction is a redox reaction because there is a change in oxidation state of the carbonyl carbon, and many of times we will say it as a disproportionation reaction. Just like if I would say that if I just would bring in a simple Cannizzaro reaction of formaldehyde. Formaldehyde when treated with OH negative, this gives me alcohol, and along with that you would get a sodium salt or salt of carboxylic acid as a formatine. So here what we will be saying that this particular carbon which is in zero oxidation state, this carbon happens to go to -2 and here it goes to the +2. So it goes from 0 to -2, that means it got reduced, and since it is coming from this 0 to +2, so it got oxidized. So it got oxidized as well. So in that sense we generally say it has to be a disproportionation reaction where same carbon got oxidized and same carbon has been reduced. Now the point here is same thing is happening here as well. If I would write the oxidation states, so this is +2, this is -2 as a matter of fact, and here if I just would write this is +1 -1, and here you have +2 -2. So the overall oxidation state on this carbon is +1. So this is +1, this is +2. Now what is the state of affair on the product side? Onto the product side, if you would see, this is -1, this is +1. Here you have +1, this is -1. So this carbon is in zero oxidation state. And similarly, if I would go for the next carbon here, you could see very categorically that this is +2, this is -2, and this is +1, this is -1. So this carbon is in +3 oxidation state. So it is quite obvious that in this particular reaction, this carbon got reduced, no doubt about it, it got reduced, and this carbon got oxidized. Very fine, it is perfectly right. So now would I be saying this has to be disproportionation reaction just like in this case, because it is a normal Cannizzaro reaction, not of the type intramolecular. This is intermolecular, one molecule and another molecule underwent reduction and oxidation. But here we will be saying this particular reaction to be a disproportionation reaction. Now, what is the definition of disproportionation reaction? For this, I have made a complete series of n factor. You can see into the playlist available onto the channel. So disproportionation reactions are those in which although same element has to undergo oxidation and reduction, but that same element must be in same oxidation state. So here the oxidation state is 0, but here the starting compound has not having the same oxidation state. This carbon is having different oxidation state. This carbon is having not is having different oxidation state. Although there is loss and gain of 2 electrons, this plus 2 goes to 0. That means it must have gained 2 electrons, and this plus 1 goes to plus 3 must have lost 2 electrons. So in that sense, it is a redox reaction. Definitely it is a redox reaction, but it would not be said as disproportionation, in the sense that for disproportionation to happen, the same element has to undergo oxidation as well as reduction. Just like if I would say that copper 1 positive happens to go to copper 0 and copper 2 positive, then I will be saying it is to be disproportionation reaction, because the same element is being reduced and same element is being oxidized, because that same element is in same oxidation state. But here the oxidation state is not same, so we would not be saying it has to be a disproportionation reaction. When you talk of a intra-crossed Cannizzaro reaction, in that you need to be little vigilant about. Okay, moving ahead. So we happen to reach to this place. So we got a salt formed. If I would write it once again for you, what basically we received with. So we started with phenyl glyoxal, and ultimately with OH negative, we happen to get a alcohol along with the salt. So this is a salt of a carboxylic acid which we have received. Now this is to be acidified. Very simple it is. When you acidify it, the carboxylic acid would get the OH group. So this H positive would come onto the O negative. So there is neutral acid being formed. Now what type of acid it is? It is alpha hydroxy acid. Alpha hydroxy acid. Do comment on to the channel that what is the common name for this acid. Common name for this acid, common as well as IUPAC name. This is a sort of homework I have given it to you. Now here you have to see one thing more, that this carbon is chiral. This carbon is chiral, or this particular compound definitely would show optical activity. It would show optical activity. If it would show optical activity during the progress of this particular reaction, you definitely would get enantiomers, and this in a way also show racemization. Racemization means that when during any reaction there are chances of getting two enantiomer being formed, you would say it would generate a racemization in the process. So it would now depend how the question is being asked in terms of the racemization or optical activity, but this particular compound would be optically. Now the point here is why I was saying that it may involve racemization, because this movement of hydride ion, because this entity, this hydride ion, because this part of the molecule is planar. This part of the molecule is planar. So H negative can attack from upper side or lower side. So this in a way can generate a racemic mixture in the process or during this reaction. Okay. So what next we have to start thought of. So we have reached to a point. Okay. Now the last step in this is that once this has been formed, it is to be heated. Now, what is this acid? This is alpha hydroxy acid, isn't it? This is alpha hydroxy acid. So you might have read that when you heat alpha hydroxy acid, what type of thing you would get. So this is alpha hydroxy acid. If I would write it once again for you, this is alpha hydroxy acid. And this alpha hydroxy acid, when is being heated, you would get a cyclic diester being formed here. Cyclic diester. How is it being formed? So this is a little factual thing which you always have to remember, which we may show it like this also. So this is phenyl, this is OH. So what would happen? This water would go out like this. So this water goes out, and here also this water goes out, and you end up getting a cyclic diester of this type. So you would end up getting cyclic diester being formed of this type. Now this also is a very important topic if you are preparing for JEE Mains Advanced and NEET examination, because many of times this particular question has been asked in terms of that what do you get when you heat alpha hydroxy acid. When you heat alpha hydroxy acid, you would get cyclic diester. Cyclic diester. And if you have beta hydroxy acid, if this is being heated, so OH from here, H from here, this would give you alpha beta unsaturated acid. This particular compound, we say it as alpha beta unsaturated acid. So this is the another point which you always have to remember. And if you have, this is beta because alpha beta hydroxy acid. Now, similarly, if you have gamma delta epsilon hydroxy acid, so what shall then be the product formed? So in these cases, just like this is alpha beta gamma hydroxy acid. So here this water goes out on heating, and you happen to get a cyclic ester, not diester, but a cyclic ester. So this cyclic ester is called as gamma lacton. So this is also a very important viewpoint here. What do we say, or what is the function group available, or what type of entity is there in lacton? Lactons are cyclic esters. So this is alpha, this is beta, this is gamma. And on to the same viewpoint, you also should remember there is a term called as lactam. Now, what is lactam? This is cyclic amide. This is cyclic amide. If you have something of this type, so we may say alpha, beta, gamma. So this is gamma lactam. So lactam and lacton can be asked in terms of what function group they are containing. Similarly, if you go for delta lacton, delta hydroxy acid, then you would get again the same viewpoint. You would get with a compound which we would say it as alpha, beta, gamma. So this is delta lacton. And similarly, you may also get epsilon naught lacton, but it is not very, the yield is not very high, but this is very popular. Which one? Alpha. So the heating effect would be seen for alpha, beta, gamma, delta. Okay, so this is quite a important one. So what next we also have to think about, because in the one of the option they people have asked us that what shall be the they are asking in one of the option uh, Z. Now let me write what we have achieved till now. So this is the this was X, we already have said about it, and this was Y, and this is Z. Now we have to do it very slowly. What are the things they have asked? So if I would mark it once again, the last step was that when we heated it, we got a cyclic diester, isn't it? We got a cyclic diester, and this cyclic diester is what you call it as your Z, and this is your X, and this is your Y. Now the point here is they also have said this has to be step 1, this is step 2, and this is step 3. So we have to now see the things very slowly, steadily, we have to understand it. So during the formation of cyclic diester, I might have missed it. There is a loss of 2 moles of water. So that is what your first statement is in the discussion. So now see what is the first option. Step 3 involves decarboxylation. No, this is wrong statement. Here we did dehydration. So there is no decarboxylation happened. So first statement in itself is a wrong one. Now moving on to the second. Step 1 involves SN2 during its progress. This is perfectly right. Step 1 involves disproportionation. This in a way is wrong. It is not disproportionation, although it is a redox reaction, but this redox reaction would not be said as disproportionation, because during disproportionation reaction, the same element is being oxidized and reduced, but that same element must be in the same oxidation state. And X is a phenoxide salt. This also is a wrong statement. It is a carboxylate salt, because if you have alkoxide, if you have O negative along with CO negative, so this O negative is a stronger base, because the OH is a weaker acid. So this would not be wanting to remain in the system as O negative. It would want to remain it as OH negative, and carboxylate can stay in the system as CO negative, because on the basis of their acidity. So that means this statement is also wrong. Now coming on to the next statement. So as I said, the question seems like easy, but it is quite engaging. Z is cyclic diester. This is perfectly right. Step 2, generate hydroxy acid. No, it is hydroxy ester. They said generates hydroxy ester. This is a wrong statement. It is actually generating alpha hydroxy acid. Step 1 involves intramolecular phenyl shift. No, it involved intramolecular hydride shift during the Cannizzaro reaction. Z may exist in 3 stereoisomeric form. This we have to check. And Y will show racemization. What was Y? This is Y. Yes, Y can show, because it is optically active, and during this progress of this reaction, it may generate racemization. Both enantiomer can be formed. What is raceme mixture? When two enantiomers are formed in equal or unequal amount, they tend to racemize each other. They tend to cancel out each other's optical activity, because that is the very definition of enantiomers, that they rotate the plane of polarized light in opposite direction with same magnitude. If they are formed in 50-50, then it is complete racemization. If one is formed 30, another is 70%, so we will be saying it is partial racemization happened. So they said that it would show racemization is a right statement. So only thing which we are left to check is with the H option, that Z would show 3 stereoisomeric form. So let me see if I could show you onto the discussion. So this is what we just have. Cyclic diester is of this type. And this cyclic diester, now we have to see in how many stereoisomeric form it can be. So if I would say these two phenyl groups are onto the same side, this phenyl and this phenyl are onto the same side, and this is H and H. In this sense, I may say this has to be cis isomer. And if I would make this phenyl here, H here, and phenyl opposite, HH opposite, then I will say it has to be trans isomer. So you can say it like this. These could be two stereoisomer in the terms of geometrical isomer. You can say it like this. Now the another thing which you can see here is that in this particular, in the cis isomer, I am not seeing any plane of symmetry, nor I am seeing any center of symmetry. So both of these are absent in this. So if I just would pass a plane from here, it is not dividing into two identical halves. Nor if I would pass it from like this part and this part is not identical, so there is no plane of symmetry. But definitely when there is no plane of symmetry or center of symmetry, we will be saying that it is optically active. So this cis isomer is optically active. If it is optically active, then this must be available in two forms, dextro and levo. So there would be two stereoisomeric forms available for this cis isomer. And in the case of trans, you definitely would see that there is availability of center of symmetry is possible. Now, what is center of symmetry? Center of symmetry is an imaginary line which, when passed from the center of an object or a molecule in two opposite direction, meet identical atoms or identical groups at same distance, then I will be saying it is having a center of symmetry. But it is not the one line you have to check in the entire molecule. If that property is available, then we will say centrosymmetry. You have not to see the one group only. Just see here, if I would go this side, oxygen at equidistance. Now if I would go this way, from here, if I would move up, I would get phenyl. If I go bottom onto the same distance, I get the phenyl as well. And similarly, if I would go in this direction also, you would get hydrogen, here you would get hydrogen, and similarly. So it is always to be remembered that the center of symmetry is to be checked with every part of the molecule, that if in entirety you are seeing such a property available, then we will be saying it is having a center of symmetry. So center of symmetry is there, so this will be optically inactive, so this is inactive, so this can be said as a mesoisomer. So this is optically inactive, so this would be available only in one form, and here it is in the two forms. So in totality, how many isomers do I get? One is this, second is this, third is this. So this particular compound is available in three stereoisomeric form. So as I said, the question was not so easy it as it seems like, but it has engaged lot many things to be checked with. So let me check what the option they have given for this. So Z mesh exist in three stereoisomeric forms. Yes, it is correct. So in totality, let me check how many correct answers do we get. So this was correct. Then E is correct, and then H and I is correct. Let me check once again. Have we done it right? So first, decarboxylation is not happening. Disproportionation cannot be said for. Phenoxide is not being formed as a salt, and hydroxy ester is also not formed. There is no phenyl shift. It is hydride shift. So in totality, how many correct answer do we get for this particular question is 4. So 4 would be the right answer for this particular question. So before I leave, because as you are all asking for, let me ask you one another question and you just see and comment. Lactide, if I would ask you what is lactide, and the another question which I gave you is what is the name of this particular compound, common name and IUPAC name. You can see into it. Have a nice day, stay safe, take good care of yourself. Bye bye.